In this lecture, we will be discussing the difference between free variables and bound variables, specifically related to the universal quantifier, quantifying our bound variables. Recall that a variable is used to represent an object in general. A variable is free if it is unattached to a quantifier and can be changed still. Think of a free variable as a single student. He's free to date whomever he wants or define himself how he chooses. Before I go on to bound variables, let's define a quantifier. The word quantifier sounds like quantify, which means an amount of something. That's basically what a quantifier does. It gives quantity to the variable. So far, we'll just be speaking about the for all quantifier, shown here by this big upside down A. Once we attach this to a variable as a subscript, just like here, we have a bound variable. This reads as for all x. X is now bound to the quantifier for all. Our single student is now taken, and so it cannot be changed or replaced. I'm going to give you another metaphor before we move on to examples to try and clarify this for you. Let's say you want to bake some cookies. You can either make them from scratch and start off with a basic dough. This dough is free to be any kind of cookie. You can take half of it and add cocoa for chocolate cookies and leave the other half plain, or add nuts or whatever you wish. If, however, you use a pre-mixed package of, let's say, ginger cookies, you must make ginger cookies. The packet of cookie mix is our for all. For all cookies, they will be ginger. You cannot change this pack of cookies. It's been printed on the packet and pre-mixed to be so. We can write this mathematically. So let's use C to represent cookies, and we'll use this symbol here to mean that the cookies are ginger. So our sentence would be, this reads, for all cookies, the cookies will be ginger. Now we can't just take away our for all, because it will completely change the meaning of our sentence. Once our quantifier is removed, we have a new statement. This statement says that we have a cookie C that is ginger. Now this depends which particular cookie we choose, and this may be true or it may be false. So it's no longer making a statement about all of our cookies, just one of them. I have one more example for you to show the importance of quantifiers. In this one, we're going to define X as a person in your class. And we're going to have a constant, B. It's going to stand for Bob. And this symbol, a little smiley face, will mean that they know each other. So the statement I'm going to make is this. And this reads mathematically as, for all people in the class, Bob knows this person. Now, in English, this simply means that Bob knows everyone in the class. Once we remove the quantifier, the statement now reads that Bob knows X. We can say that X is Clara or Henry, and then the statement will be true or false. Now that we've defined all of this, we can move on to an example that will bring all three of our new terms into play: free variables, bound variables, and quantifiers. So we're going to say that we're at a dance club. At this club, we are going to use X to represent our girls, Y to represent our boys, and this little music note to say that they danced with one another. So I'm going to give you three different statements and show you how different their meanings are. First, we start off with X danced with Y. In this statement, we have two free variables and no quantifiers. This simply means that girl X danced with boy Y. It could be Sarah danced with Joe or Harry danced with Clara. It doesn't matter who it is because we haven't yet defined our variables. They're both free to be changed into any boy or girl that was in the club that night. We can now make this statement. Which now states, for all girls, girl X danced with boy Y. So this now means that every single girl danced with a boy Y. Whether that statement is true or false depends on how lucky this boy was. But if, let's say, Harry really did dance with every single girl in the club, then this remains true. So for all of the girls danced with Harry. We can now add Y also being quantified, so now both our variables are bound, and this means that for all of the girls and all of the boys, all of the girls dance with all of the boys. Now that would be a very long night, but now both of these variables are bound to be all of each of the groups. Now I'm just going to review what binary predicate symbols we have used, or actually we use binary and unary. This refers to how many variables each of them apply to. So we started off with our ginger cookie example, which is our unary predicate, because it only applied to one variable. It could only represent one cookie, or when we quantified it as for all, it represented all the cookies, but it didn't relate to different variables. We then moved on to this one, in our example with Bob, meaning that Bob knew somebody. So this represented the variable Bob, which was a constant, not a variable actually, and a variable of a student in the class, or all of the students in the class. And in this example, I wrote it like this, where I had both of the variables to the right side of our binary predicate, and that is completely acceptable. As well as, when I used the dancing example, I put my X and my Y on either side of the binary predicate. Both of these ways of writing the binary predicate is completely okay, and both make sense mathematically. I have been fascinated with mathematics since probably I started learning it, but most in memory, grade 7. And I decided then to analyze my teachers and see how mathematics is communicated to people. And some people are better at this than others. And so I made it my mission to try and find the best way to communicate mathematics to students who may have never thought they would like it in the first place.